In exploring sustainable transportation, electric vehicles, EVs, have become a beacon of progress, transcending mere carbon emission reduction to redefine the driving experience, significantly aided by the infusion of artificial intelligence, AI. AI is crucial in augmenting EV technology across various dimensions, boosting efficiency and range, improving safety, and delivering a tailored driving journey. Enhanced battery management. At the heart of EV performance lies the Battery Management System, BMS, where AI algorithms play a vital role. They optimize battery health by monitoring temperature, voltage, and charging habits, predicting battery life, refining charging cycles, and extending battery longevity. Predictive maintenance. AI also powers predictive maintenance, foreseeing possible faults in EV parts ahead of time. By processing data from embedded sensors, AI can pinpoint irregularities, prompting preemptive maintenance actions to avert breakdowns and minimize repair expenses. Autonomous driving. AI's integration into EVs is a gateway to self-driving capabilities. Through a network of sensors and cameras combined with AI algorithms, EVs can understand their environment, decipher road signs, and make decisions in real time, enhancing driver convenience and road safety. Energy efficiency. AI algorithms excel in energy management by analyzing driving patterns, traffic flow, and terrain to suggest the most energy-efficient routes and adjust driving dynamics accordingly. This optimization not only conserves battery power, but also extends the vehicle's range, making EVs more viable for daily use. Personalized driving experience. AI-driven infotainment systems in EVs personalize the driving experience by learning from user preferences, from music tastes to driving styles, offering tailored recommendations and settings adjustments. Vehicle-to-grid integration. AI enables EVs to engage in vehicle-to-grid (V2G) interactions, allowing EVs to both draw from and contribute power back to the grid as needed. This symbiotic relationship aids in grid balance, demand peak reduction, and optimizes renewable energy use. Fleet management and optimization. For EV fleets, AI algorithms streamline operations by assessing traffic, charging station accessibility, and vehicle condition to enhance route planning and scheduling, thereby boosting fleet efficiency and reducing operational costs. Environmental impact assessment. Utilizing AI to gauge the environmental impact of EVs provides insights into their ecological benefits by evaluating energy usage, emissions, and driving behaviors. This aids stakeholders in making informed decisions towards sustainable transport. Continuous learning and improvement. AI's capability to adapt and enhance itself with ongoing data collection from real-world vehicle use ensures EVs stay at the technological forefront, perpetually improving performance, efficiency, and safety. Data security and privacy. With EVs becoming increasingly connected and AI-dependent, safeguarding data integrity and user privacy against unauthorized access becomes imperative, ensuring trust and security in EV technology. Grid load management. AI is instrumental in managing the additional load from EVs on power grids by smartly scheduling charging times based on grid capacity and renewable availability, thereby minimizing grid stress during peak times. Enhanced user experience. AI interfaces and voice assistants augment the EV user experience with real-time traffic updates, charging station recommendations, and vehicle setting adjustments, making EVs more intuitive and appealing. Regulatory compliance. As AI in EVs evolves, so must regulatory frameworks to ensure safety, security, and ethical deployment, with governments and regulatory bodies establishing necessary standards and guidelines. Collaborative ecosystem. The AI EV integration fosters cross-industry collaboration among automakers, tech firms, energy suppliers, and policymakers, propelling sustainable transport innovations and shaping future mobility. Energy harvesting and regeneration. AI optimizes energy recovery in EVs through intelligent engagement of regenerative braking systems based on driving conditions, maximizing energy efficiency and vehicle range. Vehicle-to-everything communication. AI enables EVs to communicate with other vehicles, infrastructure, and the grid, supporting collision avoidance, traffic management, and energy exchange, enhancing safety, efficiency, and grid stability. Smart charging infrastructure. AI optimizes the EV charging infrastructure, managing electricity costs and grid demand efficiently by tailoring charging schedules to benefit both consumers and utilities. Remote diagnostics and maintenance. Through continuous performance monitoring, AI enables early detection of vehicle issues, facilitating remote diagnostics and maintenance, thereby reducing downtime and maintenance costs. Consumer insights and feedback. AI analytics harvest insights into consumer preferences regarding EVs, assisting manufacturers in understanding customer needs, refining product designs, and enhancing satisfaction. Adaptive energy management. AI-driven adaptive energy management systems dynamically adjust EV settings in response to external conditions, optimizing energy use and extending vehicle range. Virtual and augmented reality integration. AI powers VR and AR in EVs to augment the driving experience with real-time environmental information, navigation aids, and entertainment, enhancing safety and enjoyment. Natural language processing and voice control. AI-driven systems enable hands-free operation of EV functions through voice commands, boosting safety and convenience for drivers. Cognitive computing for personalized assistance. Leveraging data on driver preferences and habits, cognitive computing provides personalized assistance, from charging reminders to route suggestions, enriching the EV experience. Emotional AI for driver. Well-being. Emotional AI systems assess driver mood through biometric analyses, adjusting vehicle ambiance to enhance comfort and well-being. Swarm intelligence for traffic optimization. AI algorithms optimize urban traffic flow by enabling EVs to communicate and coordinate, mimicking nature's swarms to reduce congestion and emissions. Dynamic pricing and incentive systems. AI implements dynamic pricing for EV charging to encourage off-peak charging and maximize renewable energy use, supporting grid balance and sustainability. Autonomous maintenance and repair. AI autonomously diagnoses and addresses EV issues, reducing downtime and ensuring reliability through sensor data analysis and performance monitoring. Predictive analytics for fleet management. AI predictive analytics aid in fleet optimization by forecasting maintenance needs, refining routes, and enhancing driver performance, improving fleet efficiency. Enhanced safety features. AI transforms EV safety with technologies for hazard detection, collision prevention, and driver monitoring, safeguarding drivers and pedestrians alike. The convergence of AI and EV technology marks a significant stride towards sustainable mobility, making EVs smarter, safer, and more efficient. As AI evolves, it promises a cleaner, more sustainable transportation future, underscored by constant innovation and enhanced environmental stewardship.